Okay, assalamu alaikum warahmatullahi wabarakatuh. Welcome back. So,
Walaikum salam wa rahmatullah.
yeah,
Salam wa rahmatullah.
let's continue our topic where we stop. Till now, we have discussed two
Sorry,
position
Dr. but
synthesis.
can you?
Yeah, recording. I'm sorry.
Yeah.
I was just going to press the button of recording. Okay, so what we have discussed, it's two position synthesis. Please do remember one thing which I probably mentioned in the beginning, that two position, three position, or multiple positions, more than three. Actually, it's dividing the, or it's considering the in between locations from the initial to the final position of any link. Okay. In previous examples, we just discussed two position, the initial position and the final position of any link, right? But for accurate analysis, you need to consider in intermediate locations as well, intermediate positions as well. Okay, so intermediate positions could be three. One, two, or more than one. So if we are considering one intermediate position of our mechanism with initial and the final, so that would be three position synthesis. Definitely, once you increase the number of positions, you will get more accurate solution. You will get more accurate picture of the mechanism, how it will work, but definitely the computational time will be increased. Okay, so here we are going to discuss three position synthesis of our mechanisms, right? In this example, we have coupler output, three position with complex displacement. Definitely coupler has complex motion, so it's a complex displacement here. What's the problem says? The problem says design a 4-bar linkage CD shown from position C1 D1 to C2 D2 and then to position C3 D3. It's more or less same problem, right? By the way, I'm sorry. Pivots at C and D, find the fixed pivot locations. So this link definitely, it's a moving pivot because the center of rotation is changing, okay, from initial position to the final position. Anyway, this problem is more or less same as we discuss in two position synthesis, where we discuss C1 D1 and to C2 D2, but now here we have the third location, third position of the link. Okay, these are the steps which we are going to follow. Okay, so the first step says draw link CD in its three design positions, C1 D1 C2 D2 C3 D3 in the plane as shown. Okay, design positions means definitely you will design, you know, from your problem statement that this link or this part needs to move from this location to this location. Okay, so normally not for all links, but for output link, we know the initial position and the final position at least, right, in order to design the mechanism. Like we knew rocker output, sometimes we knew coupler output or something. Okay, so based on that one, we know all these three locations, 1, 2, and 3. Okay, here again the initial conditions are not given. Okay, so we need to assume these initial conditions. What is the initial dimension of the link C1 D1? What is its initial location? Okay, and then for C2 D2 and C3 D3. Okay, it's up to you. I mean, you can just put the initial conditions here, or randomly select these points, okay, which I'm going to just select randomly, and then you will see how it will work. Okay, so let me just try to draw these links first, and then we will see how we can construct the whole mechanism in 3-position synthesis. Okay. Let me just go back to this problem. Now, first, just put the coordinate system. Scale definitely you will put. Let me just try to take in the middle. Okay. Let me just mute myself. So Fahad, your mic is open. Okay, so please mute your mics, because otherwise that would be a little bit disturbing for me. Anyway, so we can just select the coordinate system here. I would rather select here, so we will have plenty of space. Okay. Now the initial link, I'm taking the smaller one, let's say the 30 millimeter, okay? And the initial angle is, let's say 45 degrees, okay? So so 45 degrees. So scale here. And put okay. 30. It should be. So this is initial one, right? Let me just put the second. Or let's take the full one. So I'm putting 20 degrees from the x-axis. This is 10. Let's say 10 degrees. It's a little bit difficult to, okay. So let's say this is the second position. Okay, so the third position, let me just take a certain angle here. I don't know will it work or not, but let's try. So okay, so these are three positions. Okay, now let's go back to the problem. So we have drawn the first, we have finished the first step. Draw construction lines from C1 to C2 and from C2 to C3. So we need to draw the construction line from C1 to C2. It's actually the horizontal line, and from C2 to C3. So that would be the okay. And then from D1 to D2 and D2 to D3. Okay. Okay, these are the construction lines. Okay, and go back. Bisect line C1, C2, and line C2, C3. So we need to do the bisection of lines. Okay, so put the compass here and draw the arc. Okay, take the compass here and draw the arc. Okay, let me draw from here and then draw from here. It doesn't cut, so I need to draw again here. here. Okay, so we can draw the midpoint here. So we got the midpoint here, and now we need to draw the midpoint of C2, C3. Okay. Take it here. Okay. This should be drawn again here. Okay. So approximately this is the, no, I need to put the scale here. This is the midpoint. Okay. And extend their perpendicular bisector into the intersect. Okay, so we need to extend the bisectors. Okay, from here. Okay, we have the intersection point of these one. Okay. Next step. Now, are you following me? Oh my goodness.
Yes.
It's okay. So we were here. Okay. We got this first diagram on the right hand side at the top, right? We got this one. Okay. And we mark O2 point. Now we need to see four. Repeat steps 2 and 3 for lines D1, D2, and D2, D3. So again, same we need to do for these two lines, okay? D1, D2, and D2 and D3, okay? So we need to take the bisector of these lines. I'm sorry, this is a little bit messy, but let's try to see the bisector by this one so you will not be confused by arc, okay? So it is approximately D1, D2 is 20 4, let's say, right? So 12 would be the midpoint, okay? So this is 12 here, approximately here. So let me just displace the so this is the midpoint, okay? Let me extend this midpoint. Yeah, this is the problem. Now let's take the midpoint from this compass, okay? It would be good to have this. We have the same arc actually, these ones, okay? Now take here. Take there. Again, take here. It's not crossing actually. It should cross here. Okay, so now we have the midpoint here. Okay, I will extend it. Similarly, take the midpoint of D2 and D3, right? So this is dotted line here. We can take okay. Take it here. So that would be the midpoint. Okay. Okay, so we got O4 as well, okay? So please remember the downward on the left-hand side, these intersection point of these two construction line is O2, and above the intersection point of these two construction lines are O4, is O4, right? Okay. Uh, so we got till O4, okay? Now connect O2 with C1 and call it link 2, okay? Link 2 is means crank, okay? Connect O2. O2 is here with C1, okay? So let me just try to measure. So I'm measuring from 3. Yeah, it's approximately equals to 87. Okay, no, not 87. There are 3. So 10, 20, 30, 40, 50, 60. So 67. Okay, you can write the length. So L2 is 67. Okay. Go back. Connect O4 with D1 and call it link 4. Okay. Connect O4 with D1. So this is O4 and this is D1. O4. Yeah. So it is approximately 10, 20, 30, 40, 42. Okay. So L4 is 42. Okay. Is it clear till now? The drawing was simple actually. Okay. Now let's move on. Link C1, D1 is link 3. Okay. We know and we assume it 30 millimeter, right? Okay. Line O2, O4 is link 1, which is the ground. Definitely it is in between two pivot points. So let's measure. I'm not sure it's enough scale. Yeah. So it is approximately equals to 95.67. Let's take 97. Okay. So ground is L1 is 97 millimeter. Okay. So now we got all the links. Okay. Go back here. Check the Grashof condition. So let me just write it here. Again, L1 is equals to 97 millimeter. L2 equals to 67 millimeter. L3 30 and L4 is 42 millimeter. Okay. So the minimum is 30, right? Which is the coupler. Okay. So coupler is the minimum length. So L3 maximum is L1 less than or equals to L2 plus L4, and L3 is 30 plus L1 97, and it should be 67 plus 42. So this is 127, and this is 109, right? Okay. Is it clear now? It's not satisfied. Okay. Now our luck is not good. So what we need to do, if it is not satisfied, let's go back here. Check the Grashof condition. Any Grashof condition is potentially acceptable in this case. This is written here. Any Grashof condition is potentially acceptable. Any means the type of mechanism. It could be double crank, double rocker, or crank rocker, but it should satisfy the Grashof condition, right? Okay. So what is the problem? I mean, what we need to do?
Change the location of O2.
O2, yeah, it's dependent on something, right?
Yes.
We haven't choose O2 by ourselves.
We have
So
to
what we
change
need
the
to,
position.
yes, I mean, here you
of the
see the
link.
ground is little bit higher, right? The difference is approximately 18 millimeter between left hand side and the right hand side. Okay. So what we need to do, we can change the location of C2 and D2. Means might be C2 and D2 is a little bit far what we required actually. Okay. So this is how you can change the point O2, or change the angle of C2 D2, right? For example, we took 10 degrees. This was 10 degrees, right? make it more, let's say 20 degrees, okay? So once you increase the angle of C to D2, so this point O2 will become higher probably, right? Somewhere here, okay? So in this case, the ground length of grounding, I mean, which is this one, will decrease, okay? So this is one possibility, okay? So you need to please try this one. I mean, during the weekend, try to change the orientation of C to D2, or try to push it a little bit left here. I mean, this point should be moved a little bit left. So might be the O2 is going up, okay, not going down. But in my opinion, this angle is very important. We took it 10 degrees, but might be it's a little bit lower. We need to take a little bit higher angle, okay? So this is all from 3-position synthesis, okay? It will look like this one, definitely. This is the mechanism here we have. It's a 4-bar mechanism. Now, by the way, I mean, the slides which I provided you, okay? I mean, the problem number 7 is exactly almost same as, I mean, example number 6, okay? I skipped 8 and 9 problem, okay? So these are not included. I mean, these PDF, I mean, I did not hide these slides, so it did. So 8 and 9 problems, these are not part of your discussion. There is a problem number 10. Yeah, it's part of your discussion here. So what you need to do, you need to understand this problem by yourself, right? Try to replicate it, okay? The procedure is given here, and try to understand it, okay? So what we have done in this chapter, we have discussed 4, not 4 actually. Let me just open the other one. This is, where is the chapter? Yeah. So we discuss 6, 7, I mean 7 problems in this chapter, right? And 1 problem I'm giving you as a homework, right? You don't need to submit it, but you just need to figure out how you will do it, okay? Yeah, it's here. It's, now our next chapter is, do you have any question? Anyone?
Yes, doctor.
Yes, go ahead.
Doctor, in all cases for the graphs,
Yeah.
or for the position, the
Yes.
Kirchhoff condition must be satisfied or not? Or
For
some
4-bar
case
mechanism.
cannot?
For 4-bar mechanism, if you are designing a 4-bar mechanism, the Kirchhoff condition should satisfy. Okay, without Kirchhoff, it would not be considered as a working mechanism.
Okay, doctor.
Okay, okay. Anyone else? Okay, let's, this is our 3rd chapter, okay? Graphical velocity analysis. If you understood, I cannot say fully, but if you understood a lot of portion of graphical position analysis, the velocity analysis would be easier for you, okay, to understand, because definitely velocity is the first derivative of position, okay? If you remember, we discussed one thing in the beginning of our session, right? This course, that why we are doing these, right? Why we
الصوت راح.
دكتور
دكتور, we can't hear you.
Didn't hear you, doctor. في صوت يا عيال.
لا طلع الدكتور.
لا لا توصل الدكتور.
طلع الدكتور.
احمد التويجري ترى الريكوردنج تحول عندك، بالله سوي له بوز وقفه.
انتبه له لا يضيع يا رجل، محتاجه ذا.
ايه لا بس قصدي عشان لا يطلع